Hello again. So this is the second video to go along with section 1.7, which is equations in linear, quadratic, and exponential functions. But notice this time we're doing quadratic and exponentials, so I have that part underlined. Good note taking, again, make sure that you are copying these notes down as you're watching them, okay, and copy the title especially. So we're going to start with a quadratic function. And remember what we know about quadratic functions. Their graphs are parabolas, okay? So graphs are parabolas, which we know are U-shaped graphs from previous videos, okay? We also know that they have a vertex, which is a minimum or maximum point, depending on whether it's open up or open down. Okay, and that's actually going to be our next fact. Okay, so it can open down, up, or open down. I purposely wanted to put this in the same order because if it opens up, then you have a minimum, okay? And if it opens down, then you have a maximum, okay? That's always going to be true. So try to get those pictures to be able to be kind of pop up in your head when you're reading these things. It has a line of symmetry, which we also called an axis of symmetry, okay? And we saw that it can have 0, 1, or 2 x-intercepts, and it has a y-intercept. Okay, so just in exploring the graphs, we learned all of this information. Okay, there's a lot of information in that one of those previous videos. So now we're going to take a look at the equation that makes a quadratic, what it looks like, and this is the standard form of a quadratic. And the standard form of a quadratic is f of x or y equals ax squared plus bx plus c. Again, one of the videos that are coming up, we'll talk about function notation. Okay, for right now, you just need to realize that that's the same thing as saying y equals. Okay? We're going to try to explore this and see what it tells us about the function. Okay, so just by looking at the formula, what does the formula tell us about the function? So it turns out that the a value is very important, okay? The value of a tells us if the parabola will open up or down. If a is positive, the parabola opens up. So we're talking about the regular U-shaped graph. If a is negative, the parabola opens down. So we're talking about the upside down U parabola. There is a cute way to remember this. If you draw a big lowercase a, it kind of looks like a little girl with a ponytail. If a is positive, the little girl is happy. If a is negative, the little girl is sad. So positive face up, negative face down or open down. Okay, like I said, just a cute way to remember that. It also turns out, very much like linears, that this constant, this c that's by itself here, is the y-intercept. So c is the y value of the y-intercept, 0, c. Okay, so if you see that value, you know you have the y-intercept of 0, that value. Now, you can also calculate the vertex and you can calculate the x-intercepts, but we're not going to focus on those because those require other formulas, okay? They're not things that you can tell just by looking at the generic equation. So this particular section is only talking about what does the equation tell you about the function. So these are the things that we can tell just by looking at the equation. So let's do a couple quick examples. Let's say we have f of x equals 2x squared minus 8x plus 7. What do we know just by looking at this quadratic? First of all, how do we know it's a quadratic? Well, it is of the form ax squared plus bx plus c. Okay, so we know that it's of that form. And what really is causing it to be in this form is the fact that the highest exponent is a 2. So that's really what the essence of a quadratic is. A quadratic will always be a high power of 2 on the variable, on the input variable. So if this is my function, let's put out what's in each spot. A is 2, B is -8, and C is 7. And if you would like to list it out like this, you're more than welcome to do that. What does the value of A tell us? Okay, the value of A tells us that this will open up because A is +2. So I know that this is going to open up because A is positive. What does the value of C tell us? C tells us that the y-intercept is 0, 7. Remember that intercepts are always ordered pairs, so we have to write it as 0, The y-intercept occurs when x equals 0. I don't want you to take my word for that. Let's prove that if I plug in 0, I will get 7. If I were to plug in 0, remember that we plug in with parentheses, what's going to happen to these two terms? Anything times 0 is 0. And so I do wind up with an output of 7. So that's why this constant value always winds up being the y-intercept. Okay, again, I don't want you to memorize things. I want you to have a feel for why they're happening. Okay, so I know this is going to open up. I know that the y-intercept is 0, 7. And if you wanted to, and you have something to graph with, in this course, we're going to either use the graphing calculator or we're going to use Desmos, which is free. It's just desmos.com. It's a free graphing calculator online. And you can just plug this in and you can see what the graph looks like. Okay, so you can verify that these things are true. Okay, these go really quick, so let's just do a couple more. Let's say we have y equals -3x squared plus 15x. Let's identify our a, b, and c. A is -3, b is 15, c is not here. If it's not here, it's just like there was a +0 there. So the c is 0. This tells me that it is open down because a is negative. Okay, so -3. This tells me that the y-intercept is at the point 0, 0. It's going to go through the origin. And again, we don't know much about the other features. We'll learn them later on in the course, but you could always plug this directly into a technology and verify that these two facts are true. Last but not least, if I have y equals -5x² plus 4, this is still a quadratic because it still can look like ax² plus bx plus c, but what term is missing? My a is -5. My b, which is supposed to be with my x, is missing. So that means that my b must be 0, because I can rewrite this as -5x² plus 0x plus 4 if I want to. And then that leaves that c equals 4. This tells me that, again, it's open down because a is negative. And it tells me that my y-intercept is 0, 4. So those are the features that you can gather just from the equation of a quadratic, okay? Moving on to our last type of function that we explore in this course, we're now going to talk about the equation of exponential functions. And just like we did for the previous two, first let's talk about the key features. What do we know about exponentials? Well, we know that exponentials either have growth or decay, so it can only be one of those two pictures. We know that we can find the y-intercept. We know that there is no x-intercept, never crosses the x-axis. We know that there is a constant multiplier to the output for every one change in input. And that multiplier is called the factor. I just like to say multiplier because it is more descriptive. It tells you what you're talking about. And then we also learned how to convert to a rate, okay, a rate of increase or a rate of decrease. So we can actually write what these are. This is growth, this is decay. And last but not least, we learned of a relationship between growth and decay. For growth, the factor is larger than 1. And for decay, the factor is stuck between 0 and 1 because it's going to be a decimal or a fraction. So this is all the information that we learned. How did these tie into the generic form of an exponential equation? The form of an exponential equation is ab to the x. F of x equals ab to the x. B is always your factor. Well, that helps us out a lot because that's one of the key features. A is always the y value of the y-intercept. So 0, a. So every single one of these three functions does tell you the y-intercept. Okay, so that's important. That's an important feature that you need to be able to pick out of each of the formulas. So with this knowledge, okay, we're going to take equations that are written in this form and we're going to extract all the other information that we know, okay? One last reminder here, just the connection between rate and factor. Remember that factor is the percent that we keep. Rate means we have to remove the original 100% because you're only talking about the rate of increase or the rate of decrease. It's only the change that you're talking about. Okay, so we're going to go through all of those features in a chart, very similar to how we did it for linears in the previous video. So we're going to start with an equation. From that equation, I want to know if it's growth or decay. Then we want to identify the factor. We want to identify the y-intercept, and we want to identify or calculate the rate. That's the information I'd like to extract. So let's start out with f of x equals 4 times 0.95 to the x. Is this going to be growth or decay? Well, first you might want to identify the factor. The factor here is the 0.95. It is a decimal factor. It's between 0 and 1. And so this is decay. The y-intercept is this leading value. So it's going to be 0, 4, because the y-intercept always occurs when the input is 0. And the rate is going to be 0.95 times 100. So we're keeping 95%. If we keep 95%, that means we lose 5%. So it'll be a rate of negative 5% or a decay of 5%. Remember, say one or the other, don't say both. Okay? Next example. What if we had f of x equals 7 times 1.02 to the x? Identify factor first. The factor here is 1.02. This is larger than 1, so we're talking about exponential growth. The y-intercept is 0.7, and the rate comes from the fact that we are keeping 102% every time. If I remove the original 100, I'm really only growing 2% every time. Remember, it's always the difference from 100%. Next, f of x equals 0.05 to the x. This one's going to be a little tricky. We have to think about this. First, let's go in and identify. 0.05 is in place of the factor. That is a very tiny decimal, so this is decay. What is the y-intercept, though? You might look at this and say, well, there's no value for a, so it must be 0. But can it be 0? If you multiply by 0, this whole thing disappears. So it's not 0. There's always that imaginary 1 that's out in front. So really, this y-intercept is 0, 1. Think about this logically. We also know that exponential functions don't cross the x-axis. You can't tell me that this is 0, 0 because that would mean it's crossing the origin, it's crossing the x-axis, and that doesn't happen. So you can also connect it that way, okay? But if there's no term here, you can put the 1 in front. What does that mean the rate is? Well, this means I'm only keeping 5% every time. If I only keep 5%, that means I'm losing 95% every time, okay? And let's do one more. F of x equals 3 times 9 to the x. The factor here is 9. It's very large. That means that it's growth. The y-intercept is going to be 0, 3. And then the rate here is tricky. This means that I'm keeping 900%. This is very large. If I convert this to a percent, it's 900%. I take away the original 100% because I don't want to count what I started with. And so this is an 800% increase, okay? 800% growth. This should make sense because think about what doubling means. If the factor had been a 2, let's say, doubling is the same thing as increasing by 100%. So it's always going to be 100 less than what you think. So this starts with 900, it's growing 800%. Okay? Now can we put all of this together and without you just buying into it? Okay? Why should you take my word for it that this a term is always the y-intercept? Okay? The y-intercept always occurs when input is 0, right? So if I have y equals ab to the x, generic form of an exponential, and I were to plug in 0, okay? Let's actually use one of the ones up here so it's easier to see with numbers. Let's use the first one. If I were to plug in 0 to find the y-intercepts, I would have, so let's just put what we're doing here, plug 0 in for x to find the y-intercept. If I were to show that work, I'd be plugging 0 in parentheses, if you need to, for x. Put this directly in your calculator if you don't believe me, but anything to the 0 power is 1. So this is going to be 4 times 1, which is just 4, okay? And we will explore this a lot more when we get into our exponent rules. But for now, you want to make sure that you realize that if you plug in 0, this will become 1. And then that's why this leading number is always your y value for your y-intercept. So that tells me I have the 0.04 as my y-intercept. So now, again, this is so you don't just have to buy into what I'm saying. I want you to actually be able to figure out what I'm saying, okay, understand it. So let's see if we can create some ourselves. Find the equation of an exponential going through 0, 50 with a factor of 1.07. Are they telling me the factor? Yes, they are. Are they telling me the y-intercept? Yes, they are. So the factor is 1.07. The y-intercept, we know that always occurs when x equals 0. So they're giving us the y-intercept. I can plug it directly into y equals ab to the x. So this is going to be y equals 50 times 1.07 to the x. Then you can answer all the other important features like we just did in the table. Is this growth or decay? This is growth because we have 1.07 as a factor. What is the rate? Well, this means that I'm keeping 107%. If I take away the original 100, then I'm growing 7%. So I can figure out all the other important features. Okay, And then can we do it when you're given the information in a table? So let's say you had XY and you had 0, 1, 2, 3, and you had 160, 136, 115.6, and 98.26. Okay? And it said, find the equation. And they're even being nicer to you. They're telling you it's exponential. They might not even tell you it's exponential. You might have to figure it out like we did in one of the earlier videos. Because they're telling me it's exponential, I can jump in with the exponential test. The exponential test is there should be a constant multiplier that I could figure out here as long as these are consecutive inputs. So yes, I'm counting by ones, which means I can divide the consecutive outputs. I want to know what 136 divided by 160 is. Turns out that it's 0.85. Okay? I want to know what 115.6 divided by 136 is. Consecutive outputs. I still get 0.85. 98.26 divided by 115.6. Guess what? 0.85. Do I have a constant multiplier going through? Sure I do. So that's my factor. Can I also identify the y-intercept? Yeah, the y-intercept occurs when x equals 0. So put it all together. Y equals ab to the x. Y equals 160 times 0.85 to the x. And the last connection here before we leave this, end this video. This is a decreasing pattern. I should have a factor that is a decimal, okay, between 0 and 1. Yes, I do. Okay, so you always want to make sure that that coincides. Not only that, but you could take your formula and you could plug in 1 and make sure that you get 136. You can plug in 2 for x, make sure you get 115.6. So there are lots of ways that you can do little quick checks on your formula. I hope this is all making sense and it's all meshing together from video to video. Okay, each video hopefully is giving you a little more clarification to the previous video. And if you have any questions, please don't hesitate to ask. I'll see you in the next video.